Okay, so the second part of rational functions. The thing is, you already know how to do all of this. You know how to find all of the pieces that might be helpful for graphing a rational function, so you're good. That's not all though. I'm gonna walk you through it and do some examples. Hopefully you didn't just peace out right there. All right. So the steps for graphing rational functions are to find the domain. First of all, find the domain, right? Just factor the bottom and figure out what values have to be left out. Then factor the top and cancel. This is important because if we do the domain first and then factor and cancel, anything we cancel we know has to be a whole. And so that's a big important piece here. So make sure that you find the domain so that you know what's not allowed, and then find all of the places that things cancel so you have your wholes that are put in there like they need to be. The x-intercepts you need to find, put in 0 for x and solve for y. Put in 0 for y and solve. Remember, that's just going to be the numerator because when we multiply the denominator over, it just goes away. But make sure you're paying attention to multiplicities for the x-intercepts. We need to have an idea of what's going on. Find your vertical asymptotes and your HA or OA, whichever case you have. And then the optional step is number 6. You can set the function equal to your HA or OA and then solve for x to see if and when that function intersects your HA or OA, that asymptote. You don't have to do that. It just gives you another point to graph, kind of help out. And then graph it. Make sure that you have all of your dots in place and that you're connecting them in a way that makes sense, because your calculator can lie to you on this. Using something like Desmos is actually better in this case because there are times when the calculator will make it look like the graph goes up and down and then up again, when in fact that vertical line is just an asymptote. And they don't always show them, but sometimes they do, and so it's hard to sometimes trust your calculator. So be careful that you have an idea of how this really should look so that you're not just blindly copying what your calculator is doing when it's not being any smarter than its operator. So, couple of examples. Here's our first one. We're going to graph this function. So first things first, we're going to find the domain. All right. Domain is x not equal to -2. I don't even have to factor the bottom. It's just right there. Now I'm going to factor the top. X plus 4, x minus 3. Okay, that works. Over x plus 2. Means no holes. I didn't cancel anything, so I don't have any holes here. So that's kind of nice. All right. The next thing it said was intercepts. Okay, so the intercepts, the x-intercepts are going to come from the factors of the top. So x equals -4 and 3, and y is going to come from putting in 0 for all the x's. I think I'm going to get -6. If I put 0 in, I get -12 over 2. That should give me -6. Okay, so there's my intercepts. I can probably plot these now. My y-intercept is -6. A little beyond that. X, 1, 2, 3, 4, 1, 2, 3. All right, so all the x multiplicities are 1, so I'm just going to leave those there. The y-intercept's -6. It's down here. Okay, and then we still need our asymptotes. So our VA is at x equals -2. Your VAs are always going to be anywhere that you don't have a hole and you can't have your domain. So -2 would be the only place here. And this case has an OA, right? The numerator is a 1 higher degree than the denominator, so I do need to do long division. X plus 2 into x squared plus x minus 12. I need an x. X times x is x squared. X times 2 is 2x. And then subtract. Those go away. And x minus 2x is minus x. So I'll have a -1 here. And then 12 minus x minus 2. So now my OA is this. There we go. So my oblique asymptote is the line y equals x minus 1. So that's going to be x minus 1 is here. And I'm going up 1 over 1. Okay, so there we go. And then my vertical asymptote we said was at x equals -2. There we go. So now I'm going to use what I know. Here's the thing. Asymptotes have this really cool piece where if the multiplicity of the asymptote, right, so if the x plus 2 was squared, then both sides of that asymptote would be going the same direction. They'd either both be going up or both be going down. The more common case is the odd multiplicity case, right, the first, where they're going opposite directions. So if, in this case, since my asymptote has a first degree, so I'm definitely going to be going in opposite directions there, I know that I'm going to be staying in 2 diagonally across quadrants. So I think of each quadrant of the asymptotes as their own quadrant. So if I know that I'm here at -4, for x I'm at 0, then I'm looking at a graph doing that. And then the other side is doing something very similar, going off the same way. So now graph it on your calculator, make sure that that looks about right. You can always zoom out a little bit if you need to, change your window. Obviously, -5 to 5 won't work here, but -10 to 10 might for both. And make sure you're getting a good idea of what it looks like, but it should look something like this. So no holes. We do have, we have our intercepts all plotted, we have our vertical asymptote and our oblique asymptote, and we did all of that. So I do one, you do one. Here's your example. This does not have an oblique asymptote, so that's quite nice. It does have a horizontal asymptote though. So find all the pieces, find the domain, factor and cancel. This one has a hole, can you find it? What are the intercepts? What are the vertical asymptotes left? What are the horizontal asymptotes left? And then graph it, take a look at that. So try to do this one on your own, and then come back and see what I did. Okay, so how'd it go? Did you find the hole? Well, first we have to start by finding the domain. So we have that here. X not equal to 3 and -2, because I factor the bottom. And then when I factor the top, the x minus 3's can cancel. So that means I have a hole at x equals 3. Great. Now I can deal with just the reduced one. So I dealt with x plus 4 over x plus 2 as my new function. And that's where my x-intercept is -4, because 3 can't be 1. And my y-intercept is 2. If I take a 0 and sub it in, I'll get 4 over 2, or -12 over -6, depending on if you put it back in the original or in the simplified version. Either way, you should get 2. Your vertical asymptote is still at the x value that you couldn't have, so at -2. And your horizontal asymptote, no matter what, is at 1, right? Even after we cancel, we still have x over x, so that ends up working out to 1. So then I drew in my dotted lines for my asymptotes. I drew in my lines with my points for my intercepts. I did this here is optional step 6. So I did that part. It never crosses, so that was nice. You will have functions where it crosses, but this one doesn't. And then what I often tell you guys to do, especially if you're working with pencil, is as you're drawing, draw your line and then go back and say, okay, I have a hole at 3. So you go back to 3 and you erase a little spot and you put your hole in there. You do have to communicate that there's a hole there. So you need to put a little spot. Desmos and your calculator and any other graphing software I've ever found does not show you the hole. So you have to be the one who finds it. You have to be the one who puts it in there. So make sure that you're not just drawing straight over it. Show me that there is a hole there. We have to have a gap. We can get super duper close to it, but we can never equal 3 for this function. Okay, so that's it. Follow the process that I gave you, the 6 or 7 steps that we had at the second slide in this. Or go in your book and there's a set of steps that they work you through as well. So they're probably very similar, if not exactly the same. Sometimes I paraphrase, sometimes I take steps out because I think they're silly, but you can follow whatever process makes sense to you as long as you're getting all of that information that I'm asking for. Make sure that you're communicating what you actually have. So asymptotes need a dotted line. Even if you cross them, they still need a dotted line. Holes need to be holes. You need to draw a little circle where that hole should be. So make sure you're doing those 2 pieces. And remember to have labels like hash marks, that kind of stuff. I don't always know if you're using the grid as a 1-to-1 or is it 2-to-1 or is it 1-to-2, you know, how many spaces does each box count? So giving me some sort of labels really helps. And it's just how you communicate better, right? We are always trying to be better communicators, and that isn't changing in math, right? We still need to communicate well. So show me what you know, and show me what you've got. Okay, so use your calculator as a resource here, but don't trust it too much. And we'll do some practice with this in class.